Hello everyone. In this video, I'm going to demonstrate an interactive Shiny application built in R that helps us understand spline basis regression, especially B-splines, in a visual and intuitive way. Spline regression is a flexible modeling technique that allows us to capture complex nonlinear relationships by using piecewise polynomial functions. Instead of fitting a single global equation, splines divide the data range into segments and fit smooth curves that are joined together at specific points called nodes. This makes splines very powerful for modeling real-world nonlinear patterns while maintaining smoothness. The motivation behind this app is to make the concept of spline regression more intuitive. In theory, B-splines involve basis functions, degrees of freedom, and polynomial degrees, which can be quite abstract. But visually understanding how these parameters affect the fitted curves is much more effective for learning. Now let me explain the interface. On the left panel, we have two main controls. The first slider allows us to adjust the degrees of freedom, which controls the flexibility of the spline model. Higher values allow the model to become more flexible and adapt closely to the data. The second slider controls the polynomial degree of the spline basis functions, which affects the shape of each piecewise polynomial segment. On the right panel, we have the main visualization. The black points represent the observed data generated from a nonlinear function with some random noise. The blue dashed line here, shows the true underlying function, which we use as a reference. The red curve represents the spline regression model fitted based on the selected parameters. Now let's explore how the model behaves. When we use a low degree of freedom, the spline is relatively rigid and cannot fully capture the complexity of the data. This leads to underfitting where the model is too simple. As we increase the degrees of freedom, the spline becomes more flexible and starts adapting better to the nonlinear structure. At an appropriate level, the model closely follows the true function while still maintaining smoothness. However, if we make the model too flexible, it may start reacting to the noise in the data rather than the underlying pattern, leading to overfitting. So this interactive tool clearly demonstrates how model flexibility in spline regression affects the balance between underfitting and overfitting. Below the plot, we have displayed a conceptual equation of the spline model, showing it as a linear combination of B-spline basis functions. We also report the training error using root mean squared error, which helps us connect visual intuition with quantitative performance. Overall, this Shiny application provides a simple but powerful way to understand spline regression, basis functions, and model flexibility in a hands-on manner. Thank you for watching.